Today we're going to talk about midpoint and distance. So midpoint is just what it sounds like. It's the middle point, and like we hopefully looked at in class today, you can find it by doing the average of the x values and the average of the y values. So there's a shorthand symbol for average, which is x with this little line over it. It kind of looks like a bar, and that's how we read it, x bar. So my midpoint, I'm just going to abbreviate as MP, is x bar, comma, y bar. Since it's a point, it has to be the x's, comma, the y's. Or you can think of it for the midpoint as you're going to add the x and divide by 2, add the y's and divide by 2. So if I want to find the midpoint of 612 and 210, let's start with our overall structure. We're going to add, divide by 2, add, divide by 2. It's a point. X's go first. So my two x values are 6 and 2. And then my y values are 12 and 10. And now we're just going to simplify. 6 plus 2 would be 8. 12 plus 10 is 22. 8 divided by 2 is 4. And 22 divided by 2 is 11. Same thing with the next one. We just need to be careful with negatives. So if we're finding the midpoint, we're going to add, divide by 2, add, divide by 2. We're adding our x's because it's point, negative 3 plus 6, and then your y's, 5 plus negative 1. Just watch signs on this particular problem. Negative 3 plus 6 is 3 over 2. 5 plus negative 1 is 4 over 2. I'm okay if you leave it 3 over 2, or you could tell me 1.5. Both of those are fine. Please don't give me mixed numbers because mixed numbers are the devil. So no mixed numbers for us. I'm going to leave it as 3 over 2, and then 4 divided by 2 is 2. So we've already done 1 and 2, and let's look at number 3. This one is worded kind of like when we did the segments the other day. B is the midpoint of AC. So the first thing I want to do is sketch a picture. So B is my midpoint of AC. What's different than what we did on the segment day is that now they're giving me points versus before we were having expressions. So A is negative 4, 10, and C is 6, 18. What you want to pay attention to, and why I'm setting this up, is we're trying to find the midpoint. So to find midpoint, we add and divide by 2. Add, divide by 2. And you'll see why once we get to the next part of this half sheet, it's important to do your diagram and know we are solving for the middle point. And then 10 and 18. And then it's just simplifying. Negative 4 plus 6, or I like to think of it as 6 minus 4, is 2 over 2. 10 plus 18 is 28 over 2, and then simplifies to 114. So that's if I want to find the midpoint. But what if instead of finding the midpoint, they want me to find an endpoint? What we're going to do to find endpoint is to think E, M, E. E stands for endpoint. So what do you think M stands for? Midpoint. So what we're going to do with these is we're going to make a table with X and Y, and what we're literally going to do is, I'm just trying to erase this to get some space. Bye. Okay. We're going to write over here to the side, way to the side, E, M, E. Because your endpoints always need to be on the end, and your midpoint always needs to be in the middle. This seems very obvious, but when you do the problems, I'm going to have half of y'all put the midpoint first. Midpoint is always in the middle, no matter which order they give it to me in the problem. So it says find the other endpoint. Endpoint means E, M, E. Then I'm going to put my table here. And now I read the rest of the problem. If the midpoint is 2, 7, so that gave me my midpoint. My midpoint is 2, 7, and one endpoint is 5, 12. Put it on top. If we put it on the bottom, it's okay. It's just, it complicates our thinking sometimes. Now what we're going to do is, you can kind of think of it as leapfrogging, but we're going to see, how do you go from 5 down to 2? What do you do to go 5 down to 2? We're going to minus 3. So what I want to do is do that again to the 2. 2 minus 3 is negative 1. Let's try this. 12 to 7, you're going to minus 5. Do it again. 7 minus 5 is 2. So my other endpoint would be negative 1, 2. And if all else fails, you can always graph this and then just think about it from a graph. That's also totally fine. Number 2 says find the other endpoint if one endpoint is blah, blah, blah. So since it says find an endpoint, we set it up E, M, E. Put your table. It tells me the endpoint is negative 2, negative 10. So go ahead and put that in the table. The midpoint is 0, 6. So how do you go from negative 2 to 0? We're adding 2. So 0 plus 2 is 2. Careful on this one. Negative 10 all the way up to 6 is plus 16. So 6 plus 16 is 22. So that's finding the midpoint or finding the endpoint of segments. The other thing we can do with segments is to find distance. Just kidding, we have one more question. If D is the midpoint of XY, stop, draw your picture. X, Y, D. And it tells me D is 6, 4, and Y is 2, negative 1. So what is it from my diagram that is missing? I'm missing an endpoint, so what do? E, M, E. The endpoint they gave me is the Y, so 2, negative 1, and I can see that from my picture. The midpoint is 6, 4. How do you go from 2 to 6? We add 4. So 6 plus 4 would be 10. How do you go from negative 1 to positive 4? Careful. Positive 5. 4 plus 5 is 9. So my other endpoint, or point X, is 10, 9. Now I know you were waiting with bated breath once I gave you that teaser that we're going to talk about something called the distance formula. Other people might make you memorize this really crazy long formula, but we're going to use that same method we just did on the endpoint to basically help us find distance. So to find distance, what we're going to do is use the Pythagorean theorem, because the Pythagorean theorem is the one thing I can rely on 99% of students actually remembering from a math class. Anything else, who knows? But Pythagorean theorem, probably people are going to remember. So what we're going to do is Pythagorean theorem, which if you remember is a squared plus b squared equals c squared. And then we need to know that distance is always, always, always positive. And what we're going to do, if you see this random xy hanging out over here, we're going to make it a table. And kind of like EME, we're going to see how you go from one number to the other. And we're going to call whatever's happening on the left A, and whatever's happening on the right B. And those are my A and B for Pythagorean theorem, a squared plus b squared equals c squared. So here's what that looks like. First, what we want to do is put our points in the table. When we put our points in the table, you copy and paste it. When I copy and paste, it just goes in like you see it. So -1, 2, and 2, -4. I always have someone who wants to flip it. Don't flip it, just copy and paste it down. Now I'm going to look at the left side. How do you go from -1 to 2? We're going to add 3. What about 2 to -4? We're going down, and we're going down by 6 units. Now we're going to use the Pythagorean theorem with those two numbers. You don't have to write it out, but I'm just showing where we're getting this from. So the left side says +3, so I'm going to substitute in 3 squared. The right side says -6, but since I'm talking about distance, distance is always positive, so that's going to be a +6 squared. And we simplify. 3 squared means 3 times 3, which is 9. 6 squared is 6 times 6, which is 36, equals c squared. Feel free to skip any of these steps if you can do it in your head. 36 plus 9 is 45. And then we're going to do the square root of both sides. And we're just going to leave that as a really ugly square root for now. We'll talk about other things we can do with that later. Alright, so I want you to try the next problem on your own. Press pause and then check your answer. So what we want to do is copy and paste those into our table. Once again, don't flip stuff around. 5 down to -6 is -11. 5 down to 4 is -1. And when I put that into a squared plus b squared equals c squared, once again, I don't need those negatives. It's just going to be 11 squared plus 1 squared equals c squared. So 11 squared is 121. 1 squared is 1. So c is going to be the square root of 122. Whoops, I think I have the same problem written twice, don't I? Nope, similar. Okay. Put it in the table. Once you've done one of these, you've kind of done a million of them. So 5 to -6 is down 11. Oh, I copied it wrong. That's what we are having an issue with. Sorry. So my points should be to match your paper. I put them in the slideshow wrong, sorry. 5, -9, and -5, 3. Okay, I thought those looked pretty similar. Okay, so 5, -9, and -5, 3. So 5 down to -5 is -10. -9 up to 3 is +12. So 10 squared plus 12 squared equals c squared. Remember, distance is positive, so that's why I can leave off that negative. So 100 plus 144 equals c squared. And then we do the square root of both sides. So c is equal to the square root of 244. And the last one, copy it into the table. I don't know why there's an extra 0 on your in your copy. We'll just use it as the 0.12. So 1 to 3 we go up 2. 2 to 5 we go up 3. And then a squared, which is 2, plus b squared, which is 3, equals c squared. So 4 plus 9 equals c squared. 4 plus 9 is 13, equals c squared, and then we're going to do the square root. That's it. Sorry for that boo-boo on there.